You ever stop and think about how some things are even possible? Like, how can a tiny sensor stuck in a farm field miles from anywhere send back data for years on a single tiny battery? Well, today we're going to pull back the curtain on the invisible network that makes it happen. It's called LoRaWAN, and trust me, it's quietly changing, well, everything about how we connect our world.
But look, to really wrap our heads around this, let's frame it as a puzzle. Imagine you're a farmer. You need to know the exact soil moisture in a field that's way, way out there. No power outlets, no Wi-Fi, nothing. So how in the world do you get a tiny sensor to send you that data day in and day out for maybe 5, 6, 7 years, all on one little battery? It sounds impossible, right? Well, that is the exact problem LoRaWAN was built to solve. All right, so here's our game plan. We're going to start with why we even needed this thing, the IoT connectivity gap. Then we'll dive into LoRa, the spark of genius behind it all, and see how it grew into the LoRaWAN standard. After that, we'll get into the nitty-gritty of how it works, check out some amazing real-world uses, and finally, peek into the future. Let's jump in.
Okay, so our story really kicks off with the absolute explosion of the Internet of Things, or IoT. All of a sudden, we wanted everything connected. I'm talking everything from the water meter in your basement to like a single shipping container floating in the middle of the ocean. But there was a massive, massive problem. The wireless technologies we already had, they just weren't cut out for the job.
I mean, just think about the tech you use every day. Wi-Fi and Bluetooth, they're awesome for sure, but they don't reach very far. Cellular, 4G, 5G, great range, but it absolutely chews through batteries, and it can get expensive if all you're doing is sending a tiny blip of data. So this new world of IoT devices needed a totally different recipe. It needed 3 things: long range, super low power, and it had to be cheap. There was this giant gap in the market, and it was just waiting for a solution.
And that, right there, brings us to the hero of our story, the long-range spark. And what I love about this is that the solution didn't come from some massive tech giant. Nope. It came from a small, really clever French company that had an ingenious idea for a completely new way to send a radio signal.
So rewind to the late 2000s. There's this company, Cycleo, and what they did was develop a fundamentally new way to send data through the air, a way that let the signal travel incredibly far while sipping, not gulping, power. Then in 2012, an American company called Semtech spotted the genius in what they were doing. They acquired Cycleo and started to commercialize the tech under a new name, a really simple one, LoRa, as in long range. So just to recap, you've got LoRa, this amazing piece of radio technology, and you've got Semtech, the company that's ready to take it global. But having a brilliant engine is one thing. You still need to build the rest of the car around it. Because think about it. A radio signal all by itself is just, it's just radio waves. It's potential noise. To make it useful, you need rules. You need a common language, a protocol, so that all these different devices can talk to each other securely and reliably. You've got to turn a cool radio technology into a full-blown network. And this is where the LoRa Alliance enters the picture. Back in 2015, a whole bunch of different companies got together and decided to create an open standard called LoRaWAN. Now this was the absolute game changer. Open meant that anybody could build devices that would all work together. It wasn't locked down. It was the birth of a true global ecosystem. So, you might be asking, what exactly did LoRaWAN add on top of the LoRa radio? Well, basically everything else. It laid out the entire blueprint for the network, the architecture, the security protocols, device authentication, all of it. And this is the crucial part. It guaranteed that a sensor from Company A could talk to a gateway from Company B. That interoperability is what makes the whole thing so powerful and scalable.
Okay, so we've got the history down. Now, let's pop the hood and see what's really going on. What's the secret sauce here? What makes this technology tick and allows it to send tiny bits of data so far, using almost no power?
Well, the magic all comes down to something called chirp spread spectrum, or CSS. Now, instead of just blasting a signal out on one single frequency, LoRa sends out a chirp. Imagine a sound that glides up or down in pitch, like a bird call. That's what a chirp is, but with radio waves. And this unique, sweeping signal makes it incredibly tough and resistant to noise. It's like being able to hear that one specific bird call even in the middle of a loud, bustling city.
And right here, this is what that chirp actually looks like visually. See how the frequency sweeps across a whole band? And here's the really clever bit. By changing how fast that sweep happens, you can trade speed for range. A slower sweep travels much, much farther. For a tiny sensor that only needs to send a little bit of data once in a while, that's a perfect trade-off.
Okay, let's look at how the network itself is put together. It's what's called a star of stars topology. So you've got your end devices out in the field, those are the little sensors. They all send their data to any gateway that can hear them. Now the gateways are pretty simple. They're not the brains of the operation. They just grab whatever LoRa signals they hear and forward them over the internet to a central network server. That server is the brain. It figures out everything. It gets rid of duplicate messages, handles all the security, and sends the data to the right application. It's a beautifully simple, tough, and super scalable design.
Another really cool thing is that LoRaWAN is super flexible. Not all devices are the same, right? So they can operate in different classes to find the perfect balance between battery life and how responsive they need to be. You've got Class A, which is the ultimate battery saver. The device wakes up, sends its data, and goes right back to sleep. Perfect for something like a water meter. Then you have Class C, which is always listening, ready for a command right now. And Class B is a nice compromise right in the middle. Options for every use case.
And let's talk about security for a second, because this is huge. With LoRaWAN, security isn't some add-on or an afterthought. It's baked in from the very beginning. We're talking multiple layers of strong AES 128 encryption. This protects your data from the moment it leaves the sensor all the way to your application server. And that's exactly why it's trusted for really critical stuff, like managing city utilities and controlling industrial equipment.
All right, so that's the tech under the hood. Now for the really exciting part. Where is all this stuff actually being used? Where is LoRaWAN making a real-world impact today? Let's dive in.
Honestly, LoRaWAN is popping up everywhere. In smart cities, it's helping you find a parking spot and telling sanitation trucks when a bin is actually full. In smart agriculture, remember our farmer, it's monitoring soil conditions and even tracking livestock. It's used in industry to monitor heavy machinery, by utility companies for smart metering, and in logistics to track assets all over the globe. The common thread here? It's all about connecting things that before were just too far away, too difficult, or too expensive to connect.
But, and this is important, the story isn't over, not by a long shot. LoRaWAN is constantly evolving, constantly improving to tackle even bigger challenges and unlock new possibilities. So, what comes next?
Well, the standard itself just keeps getting better. They're making it even more scalable so it can handle millions, even billions of devices. They're adding things like firmware updates over the air, which means you can upgrade a device in the field without ever physically touching it. And now, with new satellite backhaul options, LoRaWAN can literally reach any point on the planet. No more dead zones.
So if there's one key thing to take away from all this, it's this. LoRaWAN isn't trying to be the one network to rule them all. It's not here to replace 5G for streaming movies to your phone. Think of it as a highly specialized tool for a very specific and very important job. It's designed to brilliantly fill that connectivity gap we talked about, connecting the unconnected and working right alongside other technologies in the massive IoT ecosystem.
And that brings us to one final thought. When you have a technology that lets you connect almost anything, from practically anywhere, for a decade, all on a single battery, the possibilities are just mind-boggling. So I want to leave you with this question. If you had that power, what problem would you solve first?